Hello everyone. In the previous video we have learnt about the resolution part, that is nothing but how to resolve a force into two rectangular components. Now in this video we will see how to calculate the total force, resultant force, magnitude as well as direction. Now let us consider a random body on which n number of the forces are acting. As here n number of the forces are acting, from that n number of the forces you will get one total force, resultant force. So we should calculate the total force, resultant force, magnitude and direction. Now before going into the calculation part, first of all we should identify the what type of the system of the force is given. So as all these four forces are acting in the same plane and acting from the single same point, so this system of the forces is nothing but a coplanar concurrent force system. Now for such a system of the forces we should calculate the total force, resultant force, magnitude as well as direction. Now to calculate the resultant we have two methods, analytical method and graphical method. Analytical method is nothing but a resolution method only. Resolution method is nothing but we have seen in the previous video how to resolve a force into two rectangular components. According to that resolution part only we have to do the analytical method, resolution method. Now before going into the resolution method procedure, first of all we should know about the rectangular components force diagram. Now what is this diagram is, if we draw the diagram which consists of only x components and y components of all the forces which are acting on one particular random body, that diagram is nothing but a rectangular components force diagram. Once again, diagram which consists of all components, x components and y components of all the forces which are acting on a body. The diagram is nothing but a rectangular components force diagram. Now what is the usage of this diagram means, nothing more, it is used for just for a easy calculation purpose to calculate the total force, resultant force. So once if we draw the rectangular components force diagram, it will be easy for us to calculate the sigma x value and sigma y value without any confusion. So we will see the procedure to calculate the resultant in the analytical method. So first of all draw the rectangular components force diagram. For that one project one x axis and project one y axis. Now coming to the given diagram, here coming to the first force, here P1 force is the first force which is in the first quadrant. So P1 force is resolved into two rectangular components, one on the x axis and one on the y axis. According to that, resolve that P1 force into two components, that is P1 x component on the x axis and P1 y component on the y axis. Similarly, P2, P3, P4 are resolved into two components in the second quadrant, in the third quadrant and in the fourth quadrant. After resolving all the forces, we got the rectangular components force diagram. Now from this diagram, if we add all the x components, you will get the sigma x value. If you add all the y components, you will get the sigma y value. Sigma x is nothing but x component of the resultant force and sigma y is nothing but y component of the resultant force. Now from this diagram we got x component and y component, two rectangular components of the total force of all these forces which are acting on this body. So from the two forces, according to the Pythagoras theorem, we can calculate the total force R value from the formula square root of sigma x whole square plus sigma y whole square, and direction theta value by using the formula tan inverse of sigma y by sigma x. This R formula is nothing but to calculate the magnitude of the total force, resultant force, and this theta formula is used to calculate the direction of the resultant force of all these forces which are acting on this body. Now once again, this is the given diagram. From that given diagram we know that this belongs to the coplanar concurrent force system. For this diagram we have drawn the rectangular components force diagram. From this diagram we got the x component and y component of the resultant force. Now from these two formulas we can calculate the total magnitude and direction of the total force, resultant force. Now after getting the magnitude and the direction of the resultant force, we can draw one more diagram. The diagram is nothing but a resultant position diagram. If we know the sigma h value, sigma v value, sigma h is nothing but x component, sigma v is nothing but y component of the resultant force. If we know the sign conventions of the sigma h value and the sigma v value, we can locate the position of the resultant force by the sign convention. For example, if sigma h is equal to positive and sigma v is also positive, then according to the sign convention, sigma h is directing towards the positive x-axis and sigma v is directing towards the positive y-axis. So according to the positive x-axis and positive y-axis, obviously resultant should be directed towards the first quadrant only. So resultant will lie in the first quadrant with the theta value according to the calculation part, that will be with respect to the x-axis, positive x-axis. So here for example, we have taken the sign convention as both values as the positive values. So resultant position will be in the first quadrant. So for the given diagram, if we draw the rectangular components force diagram as well as resultant position diagram, our problem will be more clear. This is the procedure to calculate the resultant magnitude and direction as well as position. Now let us consider one example. This is one this problem is belonging to the coplanar concurrent force system only. Now for this diagram, for this given diagram, we will draw the rectangular components force diagram. Now everyone observe the given diagram. Here 1, 2, 3, 4. 4 forces are there. So according to the resolution part, every force is resolved into 2 components. So as here 4 forces are there, 4 forces into 2 components, that is nothing but we will get the total 8 components. So obviously in the rectangular components force diagram, we should get 8 rectangular components. So we will draw the rectangular components force diagram first of all. Now coming to the first force, 30 Newton, and angle is given as 45 degrees adjacent to the x-axis. Before drawing the rectangular components force diagram, I want to tell something. If which side theta is adjacent, that side you will get the cos theta. Which side theta is not adjacent, that side you will get the sin theta. This thing you need to remember. This is coming from the basic rules only. So as here theta is adjacent to the x-axis, on the x-axis you will get the cos theta. That is nothing but 30 cos 45, force cos theta value, and on the y-axis 30 sin 45. Next, coming to the second force, 20 Newton is given and angle is given as 80 degrees. 80 degrees is adjacent to the y-axis. So on the y-axis you will get the cos theta and on the x-axis you will get the sin theta. So 20 cos 80 degrees and 20 sin 80 degrees. Now coming to the third force, 60 Newton and angle is 60 degrees. Here also 60 degrees is adjacent to the x-axis. So on the x-axis you will get the 60 cos 60 degrees and on the y-axis you will get the 60 sin 60 degrees. And coming to the last force, 40 Newton, angle is 30 degrees adjacent to the x-axis. So on the x-axis you should get the cos value and on the y-axis you should get the sin value. So 40 cos 30 and on the y-axis 40 sin 30. Now now we have drawn the rectangular components force diagram. This diagram is nothing but, if we draw the diagram which consists of all the x components and all the y components of the given forces which is given in the question, the diagram is nothing but a rectangular components force diagram. Now we have drawn the rectangular components force diagram. Now from this diagram, if we add all these x components, you will get the sigma h value. Now if you add all these y components, you will get the sigma y value. So from the sigma h value and the sigma v value, we can calculate the resultant magnitude value from this formula and direction theta value from this formula. And one more thing, according to the sign convention only, you will get the plus sign or minus sign. Here these two forces are acting towards the positive x-axis. So here you will get the plus sign. And these two forces are directing towards the positive y-axis. So here you will get the plus sign. And these two forces are directing towards the negative x-axis and negative y-axis. So for these four forces you will get the minus sign. According to the sign convention only, you need to calculate the sigma h value and sigma v value. After getting the sigma h and sigma v value, we can calculate the total force, magnitude and direction by using these two formulas. So this is the given diagram. For that given diagram, this is the rectangular components force diagram. If we draw the rectangular components force diagram, it will be easy for us to calculate the sigma h value and sigma v value. From these two formulas, we can calculate the magnitude and direction of the total force, resultant force. Now let us consider one more example. which are directly acting on the x-axis and directly acting on the y-axis. Now what is the difference between previous problem, first problem, and this problem is, in the first problem every force is acting with some inclination. If there is an inclination only, with that inclination you will get the resolution part. Now in this problem, in this second problem, all forces are directly acting on the x-axis and directly acting on the y-axis. If there is no inclination, no need of the resolution part, that is nothing but no need of the cos theta, no need of the sin theta. Here in this problem they are asking to calculate the total force resultant, magnitude value and direction value. Observe all the four forces. Here four forces are there in the given system of the forces. Here four forces are acting directly on the x-axis and directly acting on the y-axis. So no need of the resolution part. We can draw the rectangular components force diagram directly. So observe the diagram. Here 25 kilonewton force is directing towards the positive x-axis. So towards the positive x-axis you will get the plus 25 kilonewton. Next up, here 20 kilonewton is directing towards the negative x-axis. So in the rectangular components force diagram, here towards the negative x-axis you will get the minus 20 value. Next, here in the given diagram 50 kilonewton and 35 kilonewton are directing towards the negative y-axis. So in the rectangular components force diagram, here in the downward direction towards the negative y-axis you will get the minus 50 and minus 35. This diagram is nothing but a rectangular components force diagram. That is nothing but, once again, if any force is having inclination, then only you need to resolve that force into two rectangular components. If there is no inclination part, if forces are directly acting on the x-axis or directly acting on the y-axis, its own force will become its own component. Here 25 and 20 are nothing but its own x components. Here 50 and 35. Those two forces are nothing but its own y components. So according to that components we got the rectangular components force diagram. Now from this diagram, if we add all the x components you will get the sigma h value, and if you add all the y components you will get the sigma v value. Now we all know that according to the resultant main formula, magnitude formula and direction formula, we can calculate the total force, resultant force, magnitude value and direction value. Now we will locate the position of the resultant force. Now for that one, for this diagram, sigma h value is equal to positive and sigma v is equal to negative. That is nothing but x component of the resultant is directing towards the positive x-axis according to the sign convention of the sigma h value. So draw one line here that is directing towards the positive x-axis. Now according to the sign convention of the sigma v value, here minus sign is there. Minus sign is nothing but y component of the resultant force will be directing towards the negative y-axis. So here draw one line in the downward direction. So sigma h value positive, one line towards the positive x-axis. Sigma v is equal to negative, one line towards the negative y-axis. So obviously according to these sign conventions of the x component and y component of the resultant force, resultant is directing towards the fourth quadrant with the theta value. Theta will be coming from the calculation part. So that theta value will with respect to the positive x-axis. So here sigma h is equal to positive, sigma v is equal to negative. So resultant will be lying in the fourth quadrant. So this is the given diagram. This is the rectangular components force diagram. This is the resultant position diagram. So rectangular components force diagram means diagram which consists of only components of all the forces which are acting on that particular body. Resultant position diagram is nothing but position of the resultant according to the sign convention of x component and y component of the resultant force. So these are the examples for resultant force magnitude and direction calculation. In the next video we will see some more topics which are related to the first unit in the mechanics.